Namaste friends, welcome to Rhchemistry. In today's JEE MAIN 2020 bits from Nta Abhyas, I have taken alcohol, phenols and ethers chapter from which some important questions. So remember, very important point is that just now in the previous video I have discussed the same chapter NEET. So if you are a aspirant of NEET or JEE in chemistry especially, not much difference. Hence that NEET part also definitely you are going to get some help from that, and if you are a NEET aspirant you can see this also definitely it will give you a cutting edge for that particular preparation. So very important point, remember. So if you have not seen my previous videos on the JEE MAIN, please go through that. If you like the content, so share it to your friends and subscribe to the channel. Yes, in this particular case here, first question you can see CH6H5 MgBr Grignard reagent react with CS2CH2O forming A, on hydrolysis forming B. Major product they are asking. And in such case, remember, very simple, very important Grignard reagent concept. So this carbon MgBr forming OMgBr here, and this carbon is attacking on, remember, this carbon is attacking on this particular carbon, and this will form OH. So hence the product formed is, remember, C6H5 CH2 OH. So this is the product formed as a major product. So if you have not seen my previous Grignard reagent video, which is there in the tips and tricks series, very important video, please go through that. So this is very, very important point. So what is the name of this? 2-phenyl ethanol is the answer. 2-phenyl ethanol is the answer. So answer for this question is B. Then second one. See, second question is that pH 6H5 COH CS2OH H plus. X is the major product. So which is the major product they are asking. And very important in these chapters, wherever organic chemistry, OH is there and on the arrow mark H plus is there, remember, this is dehydration reaction. Remember that point. Dehydration reaction. So dehydration means it is not the point that always you have to get alkene only. So sometimes what happens, if there is a keto-enol form, then definitely it will choose keto form rather than enol form depending on the stability. So remember that point. So hence, now what will happen? See here, in this case, pH, OH, H plus. So once again, this is passed through which is the reaction mechanism? Once again, carbocation mechanism. Carbocation which is more stable. The carbocation which is attached to the carbon in which if there is a resonance, that is more stable. So because of that reason, remember, instead of removing this OH, we will remove this OH. So that the carbocation which is formed on this carbon is more stable. That I will show you like this. So pH here, CPH, this is CH2OH. Now this carbon is more stable this carbon is forming more stable carbocation because benzene ring is attached here, which will make a more stability for this carbocation. Now what you have to do? Plus is there, H plus, OH minus you are removed. OH minus you are removed, which means H plus you have to remove from this carbon. When you remove H plus from this carbon, remember minus H plus I will write. So see here, pH, right? So this will form a double bond, CH, OH, I will write it here, CHOH. Remember, this is enol form. Now this option is not given because major they are given. This option is not given, correct? So now another option we will think about. Now this will form pH, CPH. So enol form to keto form, how it take place? So this double bond will shift here and this hydrogen will shift to this carbon, right? So hence CH, C double bond O and H already it is there. So this resembles this. So answer for this question is B. Then compound A, molecular formula C4H10O on treatment with Lucas reagent at room temperature gives compound B. When compound B heated with alcoholic KOH, it gives isobutene. Compound A and B are respectively. They are not asking isobutene structure. Compound A and B they are asking. So one hint is given, you can see, you have to choose that particular hint. With Lucas reagent forming at room temperature, the compound B means at room temperature forming precipitate. So turbidity occurs at room temperature. That should be tertiary alcohol. Tertiary alcohol. Tertiary alcohol. Now if you see butane 2-ol is secondary alcohol. Right? So if you write the structure, you will come to know. Butane 2-ol is secondary alcohol. 2-methyl-1-propanol is also primary alcohol. So 2-methyl-1-propanol it is primary alcohol. See, butane 2-ol is secondary alcohol, but 2-methyl-1-propanol is tertiary alcohol because see like this. CH3, 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 OH. 2-methyl, 2-propanol, prop, right? Then definitely out of 2, one answer is correct. Out of 2, one answer is correct. When it reacts with HCl, definitely this OH will replaced by Cl. So CH3, C, CH3, CH3, Cl. This should be the product B. What's the name? 1, 2, 3. 2-chloro-propane it is. So 2-methyl, right? 2-chloro-propane, right? So this should be the answer. 2-methyl-2-propanol, 2-methyl-2-chloropropane. So here actually chloro first. It should be 2-chloro-2-methyl-propane. Here 2-chloro. This 2-methyl should come here. Because alphabetical order you have to name. So this is wrong. Name is wrong. But 2 position is correct. 2-chloro, 2-methyl-propane is the answer. And here 1-chloro-2-methyl-propane is given. Hence this is wrong. So 2-chloro-2-methyl-propane. Then this when it reacts with alcoholic KOH. Alcoholic KOH, you are going to get isobutene structure is like this. C double bond CH2 and CS3 here. This is called as isobutene. 1, 2, 3, 4. Iso, second position CS3 group is there. Isobutene is the structure. So for that reason, the answer for this question is, remember, so A. Third question answer is A. And all these are Nta Abhyas questions, remember. Now, see here. This is the compound, reactant, concentrated H2SO4, A is the product. Once again, concentrated H2SO4 means what? Dehydration. Dehydration. Dehydration, which is through carbocation intermediate. Carbocation intermediate. So these are the points you have to remember first. Then, dehydration means always alkene, so the answer is this one. Wrong, remember. This is not the low level question. It is of JE level question. Remember, you have to think in that level. So it is not the double bond forming here directly and CS it is answer. Wrong answer it is. Remember, now first what happens, I will show you. This particular cyclobutane, right? So OH is here. OH is here. CS3 and CS3. So first step, remember, formation of carbocation minus OH minus. See, formation of carbocation take place. Which carbocation to remove? See, remember, if I remove this OH, this is tertiary carbocation. If I remove this OH, this is also tertiary carbocation. But the thing is, remember, this is more stable than this because it is attached to bridge carbon. Right? So hence, this is more stable. Hence, I will remove this particular carbon, OH minus. Hence, formation of carbocation on that. So, OH as it is, C, CS3, CS3 plus. Now you can say, so OH, H from here if you remove, there is no H, remember. H from here if you remove and you will get this product. Not possible at all. Now immediately what happens? This ring expansion take place. Ring expansion take place. This is a very important concept. Remember, my dear students. Ring expansion take place. When ring expansion take place, this is going to form 5-membered ring like this. 5-membered ring like this. Let me tell you, 5-membered ring like this. Now, 5-membered ring. This is forming ring. Hence, I will write this is CS3 and this is CS3. See. Correct? This is CS3, this is CS3. Right? So, this is forming the ring here. Now, what happens is, plus charge shift to this carbon. Plus charge shift to this carbon. Hence, I will write that plus charge OH here and plus charge on this particular carbon. Understood? OH here plus charge on this particular carbon. Now there is no hydrogen here, but there is a hydrogen here. This hydrogen is removed. Remember, OH minus already you have removed. Now you will remove H plus, so that water is removed and dehydration take place. Now this H, when you remove, double bond is formed where? Double bond is formed where? Like this, and here OH, 2 methyl groups. Now this is not stable, and also this product is not given. Major product they are asking, correct? So this is forming, it is enol form, keto form you do. Keto form, what happens? This double bond will shift here and H will shift to this carbon. So that you are going to get like this, methyl group and double bond O. So this resembles this one. So the answer for this question is D. See, very important, ring expansion reaction, how it take place. Keto form to enol form, how to convert. Enol form to keto form, how to convert. These are the things you have to remember. Very, very important point. Now, very interesting question. Fifth one, we will learn here 3 different concepts. So remember here, 3 different things I have taken. One is PCC oxidizing agent, reducing agent. Now once again, reducing agent and oxidizing agent, I have made a separate video on this part. So you can go through that in the tips and tricks series. It is there. Definitely it will help you in JEE NEET preparation. Now, in this particular case, let me tell you, NaBH4 is a weak reducing agent. Always remember, NaBH4 is a weak reducing agent. It will never reduce double bond. Already OH is there, further conversion not possible, but it will convert double bond O to, remember, OH. Always NaBH4 will convert, remember, NaBH4 will convert double bond O to COH, right? That is B. Now I will tell you, this will convert, remember, this will convert C double bond O to OH, addition to that COH, addition to that, remember, double bond C double bond C also reduced by NiH2. Very important point. Then remember, PCC, simple oxidizing agent. It will not touch double bond also, double bond O also. What it will do? Simply this OH converted into double bond O. So secondary alcohol converted into ketone. This secondary ketone. A will have double bond O. Right? So hence, in all the case, same product not possible. These two are wrong. Then you can see, in both the case, product is same, right? So definitely A or B, C or D is the answer. So because for PCC, remember, it will oxidize OH to double bond O. Double bond O is there, double bond O is there. Second one you can say, second one also same. B, it will convert double bond O to OH, C double bond O to OH, B. Only the difference in C. C, what happens is double bond also reduced. Double bond also reduced in both the case, no doubt. But this C double bond O converted into OH. So C double bond O as it is here, so it is not the answer. So OH is converted, hence answer for this question is D. Like this you can solve this particular question. 3 concepts, remember, NaBH4 when to use, NiH2 what is the use, PCC what is the use. You can learn 3 concepts in one particular question. Very important question. Then 6th one. How many of the following ethers cannot be prepared by Williamson synthesis? Numerical type. How many of the following cannot be prepared by Williamson synthesis? Let me tell you this. Williamson synthesis, remember, it is alcoholic salt, that is sodium salt of alkoxide, alcohol, that is sodium alkoxide or potassium alkoxide with alkyl halide. So general reaction is like this. ROH plus RONA plus RCl give rise to ROR plus NaCl. This is the simple reaction, remember that. Now by using this, remember, this take place very easily. This reaction take place very easily, no doubt. This also take place very easily, no doubt. But this you see, C6H5 twice O to form, remember, we need C6H5Cl here. Correct? Both are phenyl group only. C6H5Cl. When I write that C6H5Cl, breaking of this bond take place here in the mechanism. But this bond is double bond character, partial double bond character due to resonance. Hence this cleavage does not take place. Hence I can say ether cannot be prepared. Cannot be prepared. Remember, this cannot be prepared. Which is not be prepared, I will put the circle and here I will put the line, which is possible. Fine. This is possible. Now, similarly, remember this is possible. C2H5 twice O. This diethyl ether, definitely it is possible. C2H5Cl, C2H5ONA if you take it, this is possible. This is possible. Now, this is also possible. Right? This is also possible because what we will do in this particular case, definitely tertiary, see, CS3ONA will take, CS3ONA, right, sorry, CS3Cl will take, CS3Cl, and CS3 thrice CONA will take. So reaction is possible. This is also possible. But both are tertiary, not at all possible. See, to form this ether, we have to take CS3 thrice CONA, CS3 thrice CCl. Both are bulkier one, very large bulky groups both are. Definitely this is not possible in this case. So hence this one is not possible, this one is not possible. Answer for this question is, remember, 2. Answer for this question is 2 because this one and this one. Now, for this question, answer I will tell you here. Consider the following two methods. Method 1, CS3 thrice CBr NaOMe. A method 2, CS3Br tertiary butoxide, sodium salt of tertiary butyl alcohol. So, sodium salt of tertiary butyl alcohol, sodium salt of methyl alcohol, and alkyl halide is tertiary here, alkyl halide is primary here. Now, which of the following is correct for the formation of ether? They are asking. Correct for the formation of ether. Now, to form ether, remember, to form ether, I will tell you, condition is that alkyl halide should not be tertiary. Remember, alkyl halide should not be tertiary. So if it is tertiary, what happens is, it is going to form, if tertiary is used, remember, if tertiary is used, this is going to form alkene as a product. So there what happens is elimination win over substitution. In this case, elimination win over substitution. How? I will tell you. See, we have CS3 thrice CBr, CS3, Br, and remember NaOMe. In this, nucleophile is OMe, andre nucleophile is OCH3 is the nucleophile. I will write it here. Now what happens is, to attack on this particular carbon, see, this Br is leaving group, this Br should leave. Definitely this is just like a SN1 reaction, SN1 mechanism. Remember, this SN1 mechanism where first carbocation should form. After carbocation, it should attack. So, but what happens is, to attack on this particular carbon, because of the bulkier nature, what happens? Instead of attack on the carbon, it will attack on this hydrogen. For example, CS3, I will write it like this, H. This will attack on this carbon and it will form a double bond here. You are going to get, and Br will be removed, no doubt. But the product you are going to get is minus NaBr. But the product is, remember, CH2 double bond C, CH3, CH3. Alkene is the major product. But if it is alkyl halide is primary or secondary, if this is a tertiary also no problem. If this is tertiary also no problem, because tertiary can attack from backside very easily. So hence remember, answer for this question, only method 2 is used. Only method 2 is used. Method 1 cannot be used. So hence this is not possible. Remember, this type of compound is not possible. So this is possible. This is possible because using method 2. This is possible by using method 2. But this is not possible. So this is very important point about ethers, remember. Then 8th question. Once again, cyclopentane ring, OH is here, CS2Cl here, AgNO3, product X is. See, AgNO3 when it is there means definitely it will take this Cl to form AgCl white precipitate. Fine. Now what happens, I will show you. What happens here? See, this is the compound. OH here, CS2Cl here. So when it is Ag plus attacks on this particular chlorine, and this particular Cl will remove as a Cl minus, remember, Cl minus, hence it will form a carbocation. It will form a carbocation. OH is here and CH2 carbocation here. See, carbocation is here. Whenever such carbocation is formed, remember, whenever the carbocation is formed in this way, it will immediately form a ring expansion reaction. This carbon bond will shift here. This positive charge shift to this carbon. Hence, I will write like this. You can see 5 carbon. Here already 5 is there. Sorry, already 5 is there. It becomes 6 carbon chain. 6 carbon chain. Right? So 6 carbon chain. And here I will write OH and also plus charges on this carbon. OH is here, you can see OH is here and plus charge on this particular carbon. Right? So correctly you have to understand, when this carbon bond will shift to this carbon, ring expansion take place, this plus charge will shift to this OH containing carbon. So that this carbon become plus charge in this particular case. So cyclopentane ring is going to form double bond O. This single bond OH is formed. Now here what happens is, I will show you. See, OH plus charge is here. Plus charge is here, it is not stable. So immediately what happens is, this particular oxygen is more electronegative. So it will give the electron to this carbon. So forming, here you can see double bond OH, positive charge on oxygen. Now immediately what it will do? It will give out this particular H. So minus H plus. Right? So because of that reason, it is going to form cyclohexanone double bond O. See, OH when it is removed, see, this particular oxygen become neutralized. So double bond O. So the answer for this question is C. See from where to where we move. So very important, this type of question. So remember that. So in this particular case, the answer is C. Next we will see 9th question. What are the products of reaction shown? What are all the products of reaction shown? Now HCl is there. HCl is there. Now Cl minus and H plus is going to attack on this carbon, this particular molecule. Now one thing is very clear. This Cl will not attack on any of these carbon, benzene ring carbon, because here there is no catalyst, nothing. Only two possibility. The one possibility, this bond undergo cleavage so that O attached to H and Cl attached to this. But this is not possible. This is not at all possible. The reason for that is, remember, this molecule is not possible, right? Reason for that is, in this particular case, this bond cleavage does not take place. So, because of that reason. So what will happen is, remember, in this particular case, this bond and this bond cleavage take place, right? So hence, H attached to this oxygen, Cl attached here. See, this oxygen carbon bond which is attached directly to benzene ring never undergo cleavage because of double bond character, because of the resonance. So now, this O and CH bond cleavage may take place, OH here, Cl here. So what is the product? CH3 twice CHCl, these two. OH, metabromophenol it form, metabromophenol. Hence the answer for this question is A. Understood? 10th one. When vapors of an alcohol are passed to hot copper, alcohol is converted into alkene quickly. The alcohol is definitely, is a direct question, tertiary. Because tertiary what happens is CS3, OH, when copper 573 Kelvin, here dehydration take place. OH from here and H from here, dehydration take place, minus water, forming CH3, CH3, double bond CH2, alkene is formed. But primary what happens is, primary for example here, CH3, CH2, OH. Now here, H from here, H from here. So dehydrogenation take place here. So it will form CH3, CHO, CHO. So secondary is also, so secondary alcohol is going to form. The ketone is going to form secondary. But tertiary, you are going to get alkene as a major product. So it will never undergo formation of alcohol or, aldehyde or ketone. So the answer for this question is C. This completes 10 questions. I hope you have enjoyed these questions. So thank you for watching. Have a nice day.